Hi students, we are going to talk about section 5.1 today. I'm going to start with just a few quick warm-up questions here. So in the figure, which angles or pair of angles fit the indicated description? So you're looking at this figure here, and you can pause this and do these, but an obtuse angle. So if I look at this figure here, I'm actually going to go ahead and fill stuff in. But if angle 4 is a 90-degree angle, then we actually know that angle 2, angle 1, and angle 3 are all 90 degrees. Now, a lot of us will then say that angle 6 has to be 90 degrees, but we do not know that. If these lines were parallel, we would know that, but other than that, we do not know. Now, just by the looks of it, if I'm talking about an obtuse angle, angle 6 and angle 7 are the ones that appear to be obtuse. An acute angle then would be 5 and 8, so angle 5 and angle 8. And then right angles, we just listed angle 1, angle 2, angle 3, and angle 4. A pair of alternate interior angles. Now remember, alternate interior angles still exist even if there are not parallel lines. So the interior angles are 3, 4, 5, and 6, and alternating sides of the transversal, if I list angle 3, and angle 6, because we want alternate interior, so 3 and 6, and then my other one would be angle 4 and angle 5. A pair of supplementary angles adjacent to one another. So supplementary angles add to 180, and adjacent means sharing a side. So they're going to share a side in this case. Now you have a lot of these. I'm just going to give one example. So angle 6 and angle 8 would be an example of that. This is another way to describe a linear pair. So if you think about that concept there, that's good that you've thought about that. Okay, so let's dive into this chapter. It's on angles of triangles. Right off the bat here, we talk about an interior angle. Now we're going to talk about interior angles, which are the angles of the triangle you think about, because we're also going to talk about exterior angles of a triangle. So we have to clarify what we're talking about here. However, if we just talk about the angles of a triangle, we do assume those to be the interior angles. So is the angle at a vertex of a triangle, because a triangle has 3 vertices, it has 3 interior angles. The triangle angle sum theorem describes the relationships among these measures. Okay, so think about that triangle angle sum theorem. So we know we have a triangle. We know we have angles of a triangle. There's 3 of them. And we know that they sum to 180. And that's exactly what this theorem says. Now, somebody did prove this. Okay, that's why it's a theorem here. But we're going to just use that idea. Okay, so if we use that idea to solve, okay, right off the bat here, if I tried to solve angle 3, I can't do that. But if I think through this problem, I look for a triangle that I know 2 angles of, which is this one here. I can add those 2 angles together, so 43 plus 74, and subtract that from 180, and you're going to get 63. So again, what I'm doing there is 43 plus 74. And so that's going to give me 117, and then I'm doing 180 because that's the total of all of the angles minus 117, and that's going to give me 63. So the measure of angle 1 is equal to 63 degrees. Once you have the measure of angle 1 to be 63, you do know that angle 2 is also 63 degrees because it is a vertical angle. So make sure we're taking those terms there. So understand that this is a vertical angle there that allows that to be 63. And then what you do from there is you now have another triangle that you know 2 angles of, and you can solve for the third. So you add your 63 and your 79 together. And you get 142, and you do 180 minus that 142, and that's going to give us 38 degrees here. So our measure of angle 3 is equal to 38 degrees. So using that angle, triangle angle sum theorem along with vertical angles, you're also going to see some linear pairs mixed into this and some parallel lines. Okay, so that leads us to the new stuff, which is the exterior angles of triangles. So we see these, we have angle 1, angle 2, and angle 3 that are all interior angles, and this is the interior of a triangle. And then we have this angle 4 over here that they've shown as an exterior angle. Now, every triangle actually has 6 exterior angles. So you can take at each vertex and extend a side. So if I extend this side, and that forms an angle, not the 180 degree one, the other angle that's here. So this is my first exterior angle right there, angle A, okay? So the exterior angle of a triangle is formed by one side of the triangle, so you're seeing that side right here, and the extension of an adjacent side. Okay, triangle has 3 exterior angles. Now I said 6 because you actually have 2 at each vertex. So we consider though this. So at this vertex, if I were to extend this side over here, that angle is exactly the same. So I can label both of those A. So either one that you want to do is considered the exterior angle there. So then you can go to each vertex and you can do the same thing. If I extend this vertex, I get B. And if I extend this vertex down here, I get angle C. And you could do two of them there. You could do two of them there, just like I did with A. Okay, so that's the idea of those. The sum of the measures of interior angles was 180. We talked about that. We talked about what an exterior angle is. And so now we have to talk about this idea. So each exterior angle of a triangle has two remote interior angles that are not adjacent to the exterior angle. So remote usually means like far away, okay? Something that's way out there, okay? So that's what that is, and they're interior angles. So if I think about angle A and I think about the interior angles that are far away, that would be angle, I should probably label these, but for angle A, the remote interior angles would be 2 and 3. Okay. However, if I look at this from the angle B's remote interior angles are 1 and 3. And then same thing with C, the remote interior angles are 1 and 2. Okay, so that's going to lead to our next idea here, and that is the exterior angle theorem. So there's actually a proof given here of the exterior angle theorem. I just think it's interesting to bring this back into perspective with our proofs and stuff. No, you do not have to do this, but given that you have a triangle ABC, so they've given that triangle here, okay, can you prove that the idea here is that measure of angle A plus measure of angle B is actually equal to the measure of angle 1? So what they do here is they say, okay, by the triangle angle sum theorem, we know that all three angles of the triangle add up to 180. And then we know that angle 2 and angle 1 that are listed here form a linear pair by looking at the problem. Linear pairs we know are supplementary, because if linear pair, then supplementary. And we know that supplementary angles add up to 180 by the definition of supplementary. So if we take these two concepts here and put them together, if those are both equal to 180, they're equal to each other. And so we have those set equal to each other. And with a subtraction property, they've got that wrong there, you can subtract measure of angle 2 from both sides to get measure of angle A plus measure of angle B equal to the measure of angle 1. Okay. Oh, sorry, I crossed out the wrong thing. There's your subtraction property right there. Okay, so that's the idea of it. Now let's talk a little bit more about this theorem here. So what we need to understand is for any of these, I'm going to come back to this picture, for any of these remote interior angles, the two remote interior angles, so in this case, like measure of angle 2 plus measure of angle 3 are the two remote interior angles to measure to angle A. So that's equal to the measure of angle A. Okay, I could do that with all three of these, as I could say that the measure of angle 1 plus the measure of angle 3, so 1 and 3 are remote interior angles to B, is equal to the measure of angle B. And you could do the same thing with C. Okay, so that's what we're getting out of that. Okay, so find the measure of angle XYZ. So we want to find this angle measure created by the triangle that's shown. So they show a tangram here. If any of you guys have not used tangrams, you definitely should. But we have this tangram, and what it's representing is we have a triangle and we have an exterior angle out here. So XYZ is an exterior angle, and so that exterior angle is going to be equal to the sum of the two remote interior angles. So we're going to do remote interior plus remote interior equal to that exterior. So I'm going to fill in what I know. So that is, I know 5x plus 15 to be the exterior angle. And then I know one remote interior angle to be 45, and I know the other remote interior angle to be 3x. And all I've done there is set up a algebra problem to where we can solve that. So we're going to subtract 3x from both sides. And I'm at the same time, once I've got that, I'm going to subtract 15 from both sides. To get rid of that. So I've gotten my x's on one side, 2x equal to my numbers on another side, 30. Divide by 2, you're going to get x equal to 15. Now, in this problem, it asks us find the measure of angle XYZ. So we need to solve for this. So we need to do 5 times 15 plus 15, so 6 times 15. And if we do that, we're going to get 90. So we should end up with the measure of that angle to be 90 degrees. Okay, so the triangle angle sum corollary. So I believe this is the first time we've heard this term here. Maybe not the first time, but we haven't seen it in a while. But corollaries really is just a theorem with a proof that follows it as a direct result from another theorem. So when we say the triangle angle sum corollaries, they're really just the triangle angle sum theorem, but maybe written in a slightly different way. Okay, I wouldn't read into that too much. Just know that that's kind of another term for theorem there. We can use a corollary and a proof as a reason, and these come directly from the triangle angle sum theorem. So this says the acute angles of a right triangle are complementary. So think about the triangle angle sum theorem that says that if you add up all of the angles of a triangle, that you're going to get 180. So if you know that you have a right triangle, so one of the angles is 90, and we have 3 angles added together equal to 180, with one of them being 90, well, I can subtract 90 from both sides and find out that those two angles are equal to 90, which is where we get to that complementary status there. Okay. And then there can be at most one right or obtuse angle in a triangle. And the idea behind this is that if we have two right angles, so if we take the same idea here and say we have two right angles, we already have 180 degrees, which doesn't leave any measure for the other angle. So that other angle can't exist. If this happens to be obtuse, so if this happens to be 91, not only does this angle not exist, but supposedly it's now a -1 degree, which also cannot exist. So what you're finding out in that last corollary there is that, again, only one right or obtuse angle can be in a triangle. Okay, so using kind of all this stuff put together, let's see what we have here. If I look at this, I'm going to look at my first triangle here. I know I have a 90-degree angle, and I have these two pieces with an x. So it looks like I can do 9x minus 8 plus the 2x minus 1. If I add those together, I get 11x minus 9. And I know that those are going to be complementary to each other, so they're equal to 90. Okay, if I solve that, add 9, you get 11x equal to 99. Divide by 11, you get x equal to 9. So I've solved and figured out that x is equal to 9. If I start to work with that, 9 times 9 minus 8. So what is that? 81 minus 8 is 73. And then 2 times 9, 18 minus 1 is 17. So we've gotten those angle measures that are there. Let's see, BAC. So again, tracing to find these angles. BAC is this one. So that's 73 degrees. BCA. So from B to C to A, that's my 17 degrees. DCF, that's this one. So those are vertical angles right there. So I'm going to fill in my 17 as well. CDF, okay, so we got to come over here and solve for Y. So on this side, I don't have that 90, but I do know that all three of those angles add up to 180. So I can do 9Y minus 1, 11Y plus 4, and 17 all put together is going to be equal to 180. So I'm going to get 20y plus, let's see what we get here, 17 plus 4, 21 minus 1, so 20. Subtract 20, you get 20y equal to 160, and divide by 20, and that's going to give me y is equal to 8. So if I solve with that, 11 times 8 is 88, plus 4 is a 92, and 9 times 8 minus 1, so 72 minus 1 is 71. Yes, that makes sense. Okay, so CDF, let's see, from C to D to F, that's my 71 degrees. And CFD is my 92 degrees there. Okay, so solving with the corollary that's there and with our triangle angle sum theorem right there. Okay, so we are going to do some problems with that.